Alright, so we're going to look at piecewise functions, and I want you first to note some definitions just because I know again this whole chapter has been a lot about vocabulary. So the first thing, a piecewise function is just a function defined by two or more equations. And that's the really simple way to put it. Instead of having just one line you're creating, you might have to create two separate lines or three separate lines or even more than that. And they could be completely different equations. Just looking at this graph over here on the right, notice that the slope here is going to be 2 up to right 1, and that the y-intercept is at 1. Okay, and notice the little open circle there. Take notice of that open circle, hence that the domain of the x's, or this equation can only be used when you're talking about x's that are greater than 0. Not greater than or equal to, just greater than 0. You would only use that one. Whereas this one down here, this equation, you'll notice the y-intercept is -2. The slope here is 1, up 1, right 1. And you can only ever use this when you're using an x that is less than or equal to, hence the closed circle. This is when you would use this equation to figure out what the value of, say, y is. That's kind of like a little quick summary of what it looks like. So look down here in example 1. Evaluate the function above using this one up here. When x equals 0 and well, let's look at the first one. A is x equals 0. Well, what I hinted to earlier, when x equals 0, you have to first figure out which equation you need to use. Well, notice that this one is only to be used when you're greater than 0. So this is asking when it's equal. So you wouldn't use this equation. But this one is when it's less than or equal to. So we got to use the correct equation. So we use this f of x equals x minus 2. Hence down here you'll see that we have that equation there. We're going to plug in when x equals 0 and solve. So when x is 0, we expect the y value to be -2. The other one was when x equals 4. Well, which equation should we be using based on the graph? Well, when x is 4, we should be using this one up here. So plug in 2x plus 1 down there. And you see hence f of x equals 2x plus 1. They're trying to find out what the y value is when x equals 4. Plug in 4 there, and we get an answer of 9. So when x equals 4, the y value or value of f is going to be 9. Remember, f of x is the same as y. All right. Some other examples. Let me close that out. Example 2. Okay. Graphing. So if we're going to go, instead of taking a graph and working backwards, let's go and do this. So the best way I can think about this is for me personally, is to graph it like you normally would. So for me personally, I see y equals -x minus 4. So the y-intercept is -4, and the slope is -1. So I personally would go and graph that there, but then I would erase all values that are not true here. So this graph says this is only true for x's that are less than 0. Okay, so we're talking about -1, -2, 3, 4, and so on. Okay, -3, -4, -5, and so on. So at 0, I know it'd be an open circle because you don't see a line underneath this. Okay, whereas on this graph, the second one, y equals x, the y-intercept is 0, and the slope is 1. Okay, so I can go graph that and just make sure I don't have the line there. And this graph is only good for x is greater than or equal to 0. So it kind of looks like this. So you'll see the first one, we'll graph the first one. Notice again, the y-intercept is -4, hence what I said there. Notice the open circle at -4, at -4, our y-intercept is -4. It's at x equals 0. And let's go graph the second one. Notice again, it's closed circle on this one, hence because it's closed up here. Slope is 1, y-intercept 0, and that's how you graph it. So if you just use if it's in slope-intercept form, it makes it a whole lot easier. I personally would graph it and erase what's not true. So only for values less than 0, hence this line right there, is true. You don't need anything over here because that's not part of that equation. And same thing for this one. You don't need anything in the negative x's because it's only true for greater than or equal to 0. All right, so let me give you some to practice. First, practice some of these. I'll give you the answers to these in a second. So you're plugging these numbers in for x into the appropriate equation, get your answers. Go ahead and freeze it to practice, and then I will give you the answers. All right, here are the answers. Check your work, make sure you did it correctly. All right, here's another set of questions you can practice based on those first two examples. All right, graph the function. Again, make sure you just graph it first, and I personally would graph it first and erase what's not needed. Personally, makes it a whole lot easier. All right, freeze the screen, otherwise here are the answers. Okay. Again, make special note, this top equation is only good for negative x values over here, including 0, hence it's over here. This equation is only good for values greater than 0, hence over here. All right, same thing over here on this side. All right, next example, example 3, write a piecewise function. So doing the opposite. So before I gave you the function piece, make a graph. Now here's the graph, make a function. So what I want you to notice here is the equation of a line. So notice the y-intercept here is 3. The slope for this line right here is 1, up 1. So I know my equation is going to be f of x equals 1x plus 3. Okay, but this is only going to be valid for points that are less than 0. Okay, because open circle, I didn't say less than or equal to, less than 0. Whereas this one, I noticed the y-intercept is at -1, and my slope is up to right 1. So it's going to be f of x equals 2x minus 1. Hence, you'll see, that's what they kind of go through here. So you'll see f of x equals x plus 3, this one right there. And then we'll have 2x minus 1, hence over here. Okay, and notice that for the range of, technically the domain is x is less than 0, and then this one is x is greater than or equal to 0. Here is one for you guys to try. All right, go ahead and freeze it and try it yourself, and I'll give you the answers in 3, 2, 1. All right. Here is another example. Some real life examples dealing with like these are called step functions. You rent a karaoke machine for 5 days. The rental company charges $50 for the first day, then $25 for each additional day. Write and graph a step function that represents this relationship between the number of days and the total cost renting the karaoke machine. So the big thing on this one is just organizing the information and putting it all together. Whatever that looks like for you might be a little different, so I'll give you a couple strategies to possibly look at. One would be using a table. So you'll notice from 0 to 1 days, 1 full day. So I say 1 day, and it's everything in between because someone could run it for just 4 hours of the day. Well, it's still $50. So anything that range is 50. Anything between 1 day and 2 day, notice that's cumulative. They have to add the extra 25, so it's going to be a $75 fee, not just 25. It's the 50 for the first day plus the other one. And then each additional day is $25 more and such. So that's a good way to organize it. All right, so what would that kind of look like? Well, once you get the information, you're going to write the step function. So f of x equals 50, 75, 100, 125, and 50. There's no really, it's not going to be a linear line that you're used to, a continuous line, because it's literally stepping up from one price point to another price point to another price point. So these are all going to be horizontal lines, hence you're not going to have a slope. You'll have a slope of 0 because it's going to be anytime between 1 and 2 days, 1.1 day, 1.1 days is, a couple hours, 1.5 days, that's 1 day plus 12 hours. Okay, it's everything in between. So this is going to be our graphs. So you have f of x of 50, f of x 75, and these are your domains for those. So it'll kind of look like this down here. So from 0 to 1, we're from open circle of 0 to closed circle at 1 because that's one's included, that one's not. Because once you hit the next one, the next day, you're going to be in the new rate. So it's always open circle at the beginning, hence 0, 1, 2, 3, 4, and all the less than signs right there. All right. So this is what is called a step function because of the fact that they're going and stepping up from each one, and that we're not just connecting a continuous line through these. All right. So it's more of a discrete data point for these versus a continuous line. All right, I'll give you one to try on your own. Read through this one and do it. Go ahead and freeze it, and I'll give you the answer, what it kind of looks like afterwards. The answer is, okay. Notice that the rental company is a $100 for the first day. Hence, for the first day, it's $100, starting at 0, going through 1, maximum 1 day. Once you hit above 1 day, you jump up to the next one for an additional $50. Hence, the total is 150 and such and such and such. All right, I hope that helps. I'll see y'all when I get back in.